Good morning, class. Welcome to this lesson on modern 9 stopping potential. Today we will be able to define and set up the equation for the stopping potential of an electron. So, in the photoelectric effect, we're going to have two plates here. We're going to have light coming in, hitting one plate. An electron will be ejected from it and go to the other plate. This is going to be in a circuit hooked up to a battery. Okay, so what is stopping potential? Well, let's go back to our definition of the photoelectric effect and the equation we get from it. This light is going to come in with an energy HF. That's energy going in. This energy is going to come out in the form of kinetic energy on the electron and the stopping potential. So a certain amount of energy goes in, some energy goes into removing the electron, the rest goes into kinetic. So how do we figure out how much kinetic energy is left over to make this electron that's left over for this electron? Well, in a simple experiment, all we have to do is adjust the voltage or adjust the potential. So notice my battery, here's the negative end and here's the positive end. So here's a negative and here's a positive end. So this is going to be the negative terminal. This is going to be the positive terminal. So let's go back to what voltage is. Voltage is the electric potential energy per charge. Voltage is the electric potential energy per charge. So if we change this equation around, the electric potential energy is equal to the voltage times the charge. So this electron is going to get ejected with an energy equal to this. Okay, so it's going to have a certain amount of kinetic energy. So what's going to make this stop? So what's going to make this take a path where it's going to come and then stop and then go back? So that is what stopping potential is. Okay, and so once we reach that certain voltage, we now know what the kinetic energy of the electron is. We now know this. Because if we know what voltage is required to stop an electron, we now know what the kinetic energy is. Because basically this comes off with a certain amount of kinetic energy, right? Well, if we give it a certain amount of potential energy in the opposite direction, so let's say it has 10 joules of kinetic, and then we give it 10 joules of potential to stop and turn around, we now know what it's going to be. Okay, not that these joules, this is a little bit wrong because joules don't have a direction; they're not vectors. But you get the point. If there's 10 joules of kinetic making something move and 10 joules of potential making something stop, it's not going to move. Okay, so basically the kinetic energy is equal to the voltage times the charge, or the kinetic energy is equal to the voltage times the charge E, because if it's an electron, we know its charge is going to be. So if we want to know the kinetic energy, this is the equation we'd have to use, or if we want to know the actual voltage, it would just be voltage equals the kinetic energy divided by the charge E.